back. Overall, I thought they were good. If you have any questions, definitely stop by my office hours sometime or make an appointment with a peer tutor. Definitely double check my adding. So the way that I grade them is at the bottom of each page is a circled number, and that's the points lost on that page. And then make sure that if those add up and actually get the grade that I put on the paper. Okay. And if you have any questions about points too, about like why I took certain amounts, stop by my office, see me after class, something like that. Okay, so today we're going to finish class 11. We started it before the quest, right? So it's been a long time since we did the demo for this lesson. So I'm going to sort of walk through it again a little bit, and then I'm going to have you work on some problems on your own. So we learned two different techniques for solving a system of equations algebraically. So a system of equations is when you have two equations with two unknowns, right? Typically what we've worked with so far in this class is one equation with one unknown, or one equation with two unknowns and you graph it, right? So now we have two equations with two unknowns, and I want to solve for the x and the y for each unknown. So the first method we learned was substitution. That's where you pick one of your equations and solve it for one of the variables. So you've got lots of choices. Pick whichever thing is easiest, right? So I picked the second equation here because solving for y would be the easiest thing, right? Because all I would have to do is subtract 4x from both sides, and y would be by itself. So in the substitution method, you pick one equation, solve for one of its variables. Then you substitute the expression that you get into the other equation, right? So my other equation was 6x minus 2y equals -3. I replaced the y with the expression that I solved for up here because y and 5 minus 4x are equal. So I can substitute one for the other because they're the same value. So I replaced the y in 6x minus 2y equals -3 with a 5 minus 4x. And then you just have an equation with a single unknown, and you can solve for the x using the old methods that you've learned in previous classes. And then once you have x, you can substitute the x into any equation that has both x's and y's, substitute in the value for x, and solve for the y. Okay. So that's our substitution method. And then to check, you take your two equations, plug in the value for x and y, and make sure both equations are true. So you can always check if you did it right. With the elimination method, this is a totally different method, but it's getting to the same goal. We're trying to figure out what x and y are. So in this case, we want to add the two equations together. And the goal of adding the two equations together is to get one of the variables to cancel out, right? So you want the number touching the x on the two equations, one to be positive, one to be negative, but they're the same number. Okay, or the number touching the y. You want one of them to cancel. You can do whichever one you want. In this example, I tried to make the x's cancel by multiplying the entire first equation by 2 and the entire second equation by -3. That made my coefficient on x be an 18 in the first equation, and in the second equation a -18, so that when I added them, 18x plus -18x cancels, and you have no x's left. And you're left with just an equation that has y's in it, which you can solve using the old methods that you know. And then once you have x, again, pick any equation that has x's and y's in it, put in the value for y or x, whichever one you just solved for, and solve for the other one. And again, you should check. And then we had a couple of special cases. Sometimes if you try to do substitution or elimination, if you end up with a crazy thing that's not true, like you end up with 1 equals 3, that's not true. That means there are no solutions. If you try to do one of those methods, substitution or elimination, and all your variables cancel, but you ended up with a true statement, like -3 equals -3, that means there are infinite solutions. All right, so I think that what I'd like to do is do one of these problems with you, and then I'll have you jump into the activities, just because it's been such a long time since we've talked about this. Okay, so we're going to start with this problem with the apples. We have 1 apple and 1 orange together make 100 calories. 2 apples and 3 oranges together make 240 calories. We're going to let X be the number of calories in an apple and Y be the number of calories in an orange. And we're going to try to write a system of equations that describes these sentences. Okay, so I'm going to translate. 1 apple and 1 orange have 100 calories. So I want to translate this to symbols. 1 apple, what symbol am I using to represent the calories in an apple? X. 1 apple. And what mathematical symbol should I use for and? Plus. 1 orange. What's my mathematical symbol for an orange here? A Y. Yep. Have, or are, right, equals 100 calories. Right? And then my next sentence, do it in another color. 2 apples and 3 oranges have 240 calories. So if I translate this to symbols, apples is X's, so I have 2 X's, and 3 oranges have, or is, or are 240 calories. So the verb in your sentence when you're translating is typically your equal sign. Is, are, have. Your verb is typically your equal sign. So I now have 2 equations with 2 unknowns, and I'd like to know how many calories are in an apple and how many calories are in an orange. So I'm going to start by solving by elimination. Okay, so I wrote my system of linear equations. I'm going to solve by elimination. So somebody pick a variable, X or Y. Which one do you want to eliminate? X. Okay, if we'd like to eliminate X, we look at the X's in my 2 equations. This one's a 1X, and this one's a 2X. I'd like them both to have the same coefficient. Okay, so what's like the least common multiple of 1 and 2? 2. All right, so I want both of my coefficients to be a 2. So I already have a 2 on the bottom one. So to make the top have a coefficient of 2, I'm going to multiply both sides of the equation by 2. Every term on both sides by 2. And in fact, I want the coefficient on that X to be -2, right? Because I want them to be the same value but opposite signs. So I'm going to multiply both sides by -2. So in my first equation, multiply every term on both sides by -2. That's why I put parentheses around the whole equation. Think about distributing that -2 to every single term. So -2 times X is -2X. -2 times Y is -2Y. And -2 times 100 is -200. Now, if I add these 2 equations together, 2x plus -2x, all the x's go away. 2x plus -2x is 0 x's. There's no more x's. 3y plus -2y is y, 1y. And 240 plus -200 is 40. So I got y equals 40. Now so I know what y is, and y is the number of calories in an orange, right? So I've answered half the question. There are 40 calories in an orange. How can I figure out how many calories are in an apple? 60. How do you know that? You got it. So you picked one of the equations that has both x's and y's. X plus y equals 100. You replace the y with a 40. And so x would have to be 60. Okay, so I solved for both unknowns, 40 and 60. All right, so that is the elimination method, where you end up adding the two equations together with the hope that one of your variables will cancel. All right, now I'm supposed to solve this system again using substitution. So I'm going to jump to another page here because I'm out of room. X plus y is 100, 2x. It's totally an individual preference. Sometimes one is easier than the other. In this case, I don't think it matters much. Typically, if it's really easy to solve for one of your variables, like in this one, x plus y equals 100, I would go with substitution if it's easy to solve for one of your variables. Oh, good question. I don't remember. After we finish the lesson and you're working, I'll look at the quest and see if I asked you to do it specific ways. Okay, so for substitution, you start with one of your two equations and solve for one of your variables. Typically, pick your easier looking equation. Which of those two equations looks simpler? X plus y equals 100. Solve for the variable that's easier to solve for. It's both the same, yeah. So which one do you want to solve for? X. Okay, so if I solve for x, I just subtract y from both sides. Right, so I get x equals 100 minus y. So then my substitution step, why we call this substitution, is that in the other equation, wherever you see an x, you can replace it with what x equals. Okay, they're the same, so you can substitute one for the other. So in my next equation, I have 2. Instead of an x, I'm going to put in a 100 minus y. They're the same value, so I can replace the x with a 100 minus y. And I have plus 3y equals 240. And now I have just an equation with one variable in it, just y. And I can solve this. I could distribute the 2, so I have 200 minus 2y plus 3y is 240. Negative 2y plus 3y is y, so I have 200 plus y is 240. Subtract 200 from both sides, and you get y equals 40. So that's the number of calories in an orange, right? Number of calories in an orange is 40. And then if I want to know the number of calories in an apple, I can go back over here to this x equation. X is 100 minus y. I now know what y is. So I have x equals 100 minus 40. So x equals 60. So that's our substitution method. Two methods, elimination and substitution. And the class before this one, we were solving these things graphically, right? So if I graph these two equations, this one is the equation x plus y equals 100. This one is the equation 2x plus 3y equals 240. So in the class where we did this graphically, you graphed the lines yourself. Today I'm giving them to you so that you can just double check your answers. The place where those two lines cross is the solution that should be the solution we found algebraically. This is the point 60, comma 40. X is 60, y is 40. And that's the solution we found algebraically. I know it's kind of a lot, and you won't digest it until you try to do a few on your own. Call me over if you get stuck. Have fun. Okay, so we're going to look at some applications of systems of linear equations. Okay, so those are like word problems, right? They involve total value and investment problems. So for example, let's say we have two types of candy. One of them sells for $2.50 a pound, and the other one is $4 a pound. Okay, so a store clerk is trying to make a mixture worth $11.70. And they want twice as much cheap candy as expensive candy. Okay. So you're going to put together a mixture that has a lot of cheap candy, some of the more expensive candy, and they want the total cost to be $11.70. How much of each type of candy should be included in the mixture? Okay, so here are our steps. We're going to define our variables. So let C be the cheaper candy, the number of pounds of the cheaper candy, and E be the number of pounds of the expensive candy. So sometimes it's helpful to use the letter to help you remind you what it stands for, like C for cheap and E for expensive. But if you like X and Y, you can always just stick with X and Y too. It's a personal choice. All right, and then I made this little table, right? So we've got items, which is cheap candy and expensive candy, right? Then we have the number of those items, or how much of those. Then there's the cost per item, and then the total value. Okay. So for the cheap candy, we have C pounds, and the expensive candy, we have E pounds. The cost for the cheap candy is $2.50 each pound, and the expensive candy is $4 per pound. So then my total value, if you want to know how much the cheap candy costs, you multiply the number of pounds times $2.50 per pound. So we get 2.5 times C. And if you don't know, if you can't figure out that you should multiply those, you can always pick a number. Like, pretend I have 10 pounds of cheap candy. I have 10 pounds, $2.50 per pound. You multiply them to get $25. So this is 250C, and this is 4E. And then my total value of the mixture is $11.70. So I put that in my total value column. Okay, so now we're going to write a system of equations. So we're going to look at our table that has all the information we organized from the sentences, and we're going to try to come up with what equals what. We're going to write two equations. So one equation is going to talk about the number of items, and the other equation is going to talk about the value of those items. So we had this sentence up here that said, twice as much cheap candy as expensive candy, right? So you're going to double the amount of expensive candy to figure out how much cheap candy there is. So cheap candy is double the expensive candy. Okay. And then, so that's the amount sentence. And then this is the value sentence, where 250C, that's the value of the cheap candy, plus 4E, that's the value of the expensive candy, altogether should add up to 1170. So there's a typo in your notes if you want to fix that. So I'm going to let you solve this at a later time. This is the skills that we've been working on in the previous lesson, solve that system of equations. It turns out that the solution is you should use 2.6 pounds of cheaper candy and 1.3 pounds of the expensive stuff. All right, so that's one kind of word problem that results in a system of equations. A total value problem, that's called. Okay, so now another kind is an interest problem, an investment problem. Okay, so the amount of money that's deposited in a savings account is called the principal, and the money a person earns from the bank is called interest or interest income. So if money is invested for 1 year, then the interest is just the principal times the interest rate that the bank agrees to pay you. Okay? They pay you some percentage of how much money you have in the bank. So for example, let's say Jerry invested a total of $2,000 in 2 different banks. So he took his $2,000 and he put some of it in bank 1 and some of it in bank 2. The first bank pays 4% interest and the second bank pays 9% interest. So his yearly income from the 9% investment is $37 more than the yearly income from the 4% investment. So you would think that you would make more money off of your higher interest bank account than your lower interest bank account. So how much did he invest in each bank, right, at each rate? So you start by defining your variables based off the question, right? So we identify the question. How much did he invest at each rate? So we want to know how much he invested at the low rate and how much he invested at the high rate. So I let L be the amount he put in at the lower rate and H be the amount he put in at the higher rate. So then I organize everything into a table, right? So I've got two investments, a low rate and a high rate, and I have a total investment. So L and H, the amount I put into the low and the high, I don't know what those are, so I just put in the L and the H. Okay? And my total investment was $2,000, Jerry's total investment. The lower interest rate is 4% and the higher interest rate is 9%. And then the amount of interest income you get by multiplying how much money you put in times the interest rate gives you the amount of interest earned. So for example, if you invested $100 at 4% interest, you would have earned $4, right? 100 times 0.04, $4. So you multiply 0.04L and 0.09H. So notice that in both of these two examples, we multiplied the first two columns to get the third. That's really common. Okay, so now we got to try to come up with a system of equations, okay, based on the information in the table and the information given in the sentences. Okay, so we know that altogether the investment is $2,000, so L plus H has to be $2,000. The amount you put into one bank plus the amount you put into the other bank has to add up to $2,000. So that's your equation, L plus H equals 2,000. And then my other equation comes from this sentence. His yearly income from 9% is $37 more than his yearly income from the 4%. So this is my income column. So that's how those are the expressions I'm going to use to translate that sentence into an equation, into mathematical symbols. So his yearly income from 9%, mathematical symbol for his yearly income at 9% is 0.09H. Okay, so I translate that. His yearly income from the 9% investment, that's 0.09H. Okay. That's an equal sign. Okay, the verb is your equal sign. $37 more than, what mathematical symbol should I use for more than? Plus. More than his yearly income from the 4% investment, which is 0.04L, his yearly income from the 4% investment. So that's the second equation. 0.09H equals 37 plus 0.04L. So I just translated, like phrase for phrase, the sentence they gave me into symbols. That's what you're going to be doing. L plus H equals 2,000. Because the amount he put into the low investment plus the high investment, he invested a total of $2,000. So again, I'll let you try solving this at a later time. You could use substitution or elimination. It turns out that you should put $1,100 at 4% and $900 at 9%. So we have this step-by-step process outlined below for how to solve a word problem that involves a system of equations. Step one is always define a variable, right? Identify the question and let your variable be the answer to the question, right? How much candy should I choose? How much of each kind of candy? Let X be candy 1 and Y be candy 2, right? So use your variable to answer the question. Step 2, make a table, right? So we try to organize a table that looks like this. So we have object or item or quantity, like the things we're talking about. Then we have quantity or amount, item or unit value, and total value. Okay, so this chart would be a good thing to put on a note sheet, right? Being able to make this chart for yourself. Then you have to write out a system of equations. You need to determine the relationships in the problem. What is equal to what? What is connected to what in some way before you can write equations. Okay. Use one of the methods that we've learned, graphing, substitution, or elimination to solve the equations, and then check your answer and describe your results with a sentence, relating it back to the actual question asked. Okay, so in your activities, I gave you some charts to help you get started. And if you did not finish the solving systems of equations activities, you can go back to that, and and then we'll pick up with some time to work on, more time to work on these activities next class. Yes. So, oh, okay. Oh, there we go. So, okay, $5, yes.